Welcome all. In the next lecture of the backtracking algorithms, now this particular lecture will be used to tell you what you mean by state space tree, and generally in all backtracking algorithms, if you can design this state space tree, it will try to elaborate to you that how many solutions are available and from which you will try to find a pattern. So now from all other videos in the backtracking, this state space tree is very useful, that you can able to see that, and it's very easy to design this tree, and this is a visualized method to get how your actual recursion is working, and then from that you can able to check the depth of the tree, and from the depth of the tree you can able to see that when you arrive at the solutions, and you have to stop from that thing. So let's take one example of what is state space tree. Now our favorite example, the four queen problems. You have given total 4 cross 4 chessboards, 1 2 3 4, 4 rows and 4 column. Now you have to put queens, 4 queens. So consider that if I am putting a one queen here, now this particular queen can go to row here, here, even this can go to here, the row, now here also, and here also. So we have to put a queens like this, total 4 queens. So it's very obvious that in each row only one queen is possible, and we have to make sure that no queens is going to attack in any other queens. So now our task is, from that theory we have to draw the state space tree, and from that tree we will detect that how many solutions available to this problem. That will be a very useful thing, and even in our further lecture series we will see that how backtracking is connected with other techniques in the algorithms. That way this state space tree is very useful. So that's why this particular lecture will dedicate to explain to you, for a given problem, how can you design the state space tree, check the patterns, and from that you can tell that which algorithm technique can be tried to cultivate to solve this particular problem. So let's take this example of a 4 queen. Of course we can take also a 8 queen problem, but that graph will be much more used, that is not able to fit in this slides. So that's why a 4 queen will be chosen. So it's a nice and very kind of understandable way to understand what do you mean by state space tree. So let's start with this. So every time I have put you for this 4 cross 4, this will be very useful. So now what is this conventions that we are going to one by one look. Now 1 2 3 and 4, so this will be represent a first row the queen positions, second row queen position, third and fourth row, and this will be the level in the tree because we are going in the depth of the tree. So this level will tell that when we supposed to stop, that will be helpful. So right now we have empty chessboard. Now the question is, why we have empty chessboard, why always we start in backtracking with empty solutions? Because in algorithm for every problem solution exists. Okay, only thing is we have to find that particular way to solve that particular problem. So now this particular all 4 0 here will represent this particular empty chessboard. Yeah, so now you will get it how to relate this thing. So let's try to move ahead. Consider this particular value. Okay, so first it will come here and this thing, let me use the right one. Now what is the meaning of this thing? 1 2 and 3 and 4, this is again a level, so this color you will try to utilize only for the level. Now 1 0 0 0, 1 means in the first row I am putting the first queen in the first column, so this will be the column number in which you are going to place the queen. Now here we haven't yet placed the remaining 3 queens, so that's why this particular 1 0 0, this will resort to this particular chessboard design. Clear? So now if we want to use, let's say This one. Now how can we relate with the chessboards? Well, this will tell that in the first queen will be placed in the second column. So this particular relate with this particular design. Okay, so this will be a numeric notations, this will be a GUI based notation. So whichever you want to use, you will use both the things. That is fine for you. Now what about 3? For 3, yes, I am putting a first queen in the third column. So that's what this particular notation will tell you. Now about this 4, well, I am putting a queen, first queen in the fourth column. So that's what 4000 meaning. So this is a numerical notation, this is GUI based notation. Yeah, so let's go to next. We will try to get all the 3. Now how this will be called? It is not a breadth first search, it's a depth first search. So that's why it's very important that how it is supposed to be called. So let's start from here. Our root. Right now our chessboard here will be equivalent to this root. Now first it will be called here the first queen. So first queen they are putting here. So this thing will be represent to this particular notations. Now again it will go to the depth first. So now this will be called this one, and here we are putting the second queen in third column. So this is second queen in third column. So this particular GUI will represent this particular numerical value. Now we can able to easily see that the moment we have put the second queen in the third column, can we put the third queen here? No. Second here third queen, no. Second column, no. Here in the third column, no. In the fourth column, no. It means now we cannot place a third queen. The moment we cannot place a third queen, we have to backtrack. That is what there. And we have to explore that, can I go with the second child? Here, no. So here, now about this particular second queen, do I have any other place other than this location in the for the second queen? Yes, this will be the second location. It means now this third queen, second queen, apart from this third column, we are putting this fourth column. So that is 1400. So this will be this thing. Now again we will ask, can we place the third queen? Here, no. Here, yes, we can put the third queen here. 1, 4, 2 and right 0. Now what about the fourth queen? Here, no. Here, no. Here, again no. It will be attacked by this queen. Here, again no. It means the moment you will come here, there won't be any further solutions. So you again have to backtrack. Yeah. Again you have to backtrack here. This is a parent. Again you have to backtrack here. This is a parent. Now you have to check whether do you have any other particular next move available, because this particular things won't give you the solutions. So now what you have to do, you have to put the first queen in the second column. Yes, I can put the first queen second column. So this will be my particular solution. Now again I will go to the depth. I will check what about the second queen. Second queen here, no. Here again no. Here no. Yes, in the fourth column we have put. So this will be my this particular locations. Again what about the third queen? Here I can put the third queen. Yes, I can put the third queen. So this will be my particular location of this queen. Now what about the next fourth queen? Here I cannot put. Here I cannot put. Yes, here I can put in the third column. So now this will be represent to this. The moment you will reach to the 5, this is the depth of the tree. The moment you reach to the 5, you have to stop from here. So this will be one of our solutions that we can able to see. Okay, now we don't have to call further in the down. So what you have to do is we have to backtrack from here. Okay, so this queen we again here. Now we have to find, is there any other suitable locations for the third queen other than this one? Here no. Here no. Here no. It means again we have to go backtrack. So again we have to go to backtrack. Now already the second queen we have put at the fourth locations, so we don't have any other place to go it. Again we will go backtrack. Now we have to check here. So we have to again go to the backtrack. the parents. So now we will check the third locations. So now this particular queen, let me try to yes. Okay, so what we can do, we will put the queen, first queen, in the third locations. Then again we are calling, yes, this queen I can put it here. So this will be represent, now this is what the first, then this will be call, this will become our seconds. Again we will call in the details, the third queen we will put in the fourth locations. Yes, now what about this fourth queen? The fourth queen we will put it here. Oh yes, we will reach to the depth of the tree. So we'll stop here. This will be our solution vector that we can see. Okay, so now we don't have to go further. Again backtrack. Now we don't have any other remaining location for this particular third queen. So again we backtrack. Now we don't have any other locations for this particular second queen. Again we backtrack. Again we backtrack to the parent. That's what I've called. Now we will explore to the next particular children's. Okay, so now we will explore this particular children's. So this will be 4, so this will be this 400. Okay, now we have to put about this queen. Second queen I will put here, so this will be my this particular node. Again for the third queen I am going to put it here, so this will be my particular node. The moment I put the third queen, I don't have any other place to put the fourth queen. It means I will backtrack. Again I will check it out. Here this I have put. Now do I have any other place for the this queen? Now what I have to do? Yes, this first second queen, in place of first I will put it here. So that will be my second solutions here. The moment you put the second queen here, for the third queen, no, no, again no, this one no, this one I don't have, this one I don't have, and this one. It means again I have to backtrack. Yeah, again I have to backtrack from the parent, and then I'll check it out. Now the first queen I already put at the fourth locations. It means I don't have any other particular locations available. So now this will be my state space tree for a 4 queen problem. Similarly, you can design the state space tree for a 8 queen problems, that is much more bigger, but ultimately this will give you what is the way the recursion will be called, how the solution will be generated, and how many solutions will be generated. In our future videos we will see that this state space tree will be utilized to find out a techniques. So it's like, if any new problem will be came to you, you will try to use the backtracking first, design this particular state space tree, entire kind of things, and by looking at this particular diagram and looking at the solutions, the way it is derived, you will try to find out what is the pattern in the solutions, and then from that you can decide which technique will be useful. So that will be a one kind of unique thinking behind the use of backtracking, and the state space tree is playing a key role in the problem solving approach. Okay, so you, for further details you can refer the syllabus, the textbooks that is referred in the subject, the NPTEL videos, MIT, any other relevant material on this thing, the state space tree. Also you can search in the Google to get it what you mean by state space tree, and have a look at how the people are designing for a given problem solving approach. Thank you all for watching this video.